In this video, we want to discuss uniform probability distributions for continuous random variables. In this section, we don't need to use our Rguroo to calculate any of the things in this section. However, there is the option to calculate these using the probability calculator. But the mean and standard deviation we will be doing using a basic formula. And I say basic because there's not many steps. So to get these formulas initially, if you hit this tutor button while you're in the practice, then you can get these formulas. So again, this is for a uniform distribution. Recall that uniform distributions look like a rectangle. And continuous uniform distributions, when we talk about probability, we're talking about the area of the rectangle that's defined by the probability statement or event that we're trying to conduct. And very different from discrete. So we just finished up chapter 7, which was discrete random variables. Recall that discrete is countable. Okay, finding the probability that exactly one person attends my lecture versus exactly two is probabilities that we can point to. Probability of exactly one, exactly two. There's nothing in between. There's no half a person or any kind of attendee count between one person and two person. Very different from the continuous world, where if I was trying to find out the probability that people walking in the next 10 minutes into class, okay, so even if I'm counting by minutes, 1 minute, 2 minute, 3 minutes, I hope we can agree that time is continuous and that there's infinitely many units between minute 1 and minute 2. And therefore, we consider probability for continuous random variables to be the area under a curve. And it's specifically for the uniform distribution. That curve is more of a rectangle. Okay, so to find a mean for a uniform distribution, you will use a basic average formula. Okay, A and B represent your beginning and your end point. So in the example here, talking about a manufacturer and a uniform distribution between 58 and 70 ounces, A would be 58 and B would be 70. So to calculate our mean, we would add 58 plus 70 and divide by 2. For standard deviation, notice this is a standard formula, so we would subtract our endpoints, and you'll always be dividing by the square root of 12. Now, where that formula comes from, we'd have to derive it using calculus, but you don't have to worry about deriving formulas in this course. We just need to write these down and use them for 8.1. Okay, so for this particular problem, if I wanted to find the average, I want to calculate A plus B divided by 2. I'm going to use the calculator here in our Rguroo. So if I come to Applets and Calculator, open up this calculator folder and just double click on the scientific calculator. This isn't anything fancy or other than any other calculator that you can use. It's actually a Desmos powered calculator, but it's good to get comfortable with because as we progress through the semester, we will have to do some calculations prior to entering them into an Rguroo calculator, probability or analytics. And rounding before a final result can always potentially throw off your final answer by just enough where Hawks will tell you you are wrong. So we will be using this calculator so we can copy and paste exact decimal places, reducing our error and pasting them into another area in our Rguroo. So for this particular problem, again, I got to double check my endpoints, 58 and 70. So I'm going to add 58 plus 70 and divide that by 2. And that shows me that my average for this uniform continuous distribution is 64. And for my standard deviation, following that formula that I found in the tutor button, I'm going to subtract my endpoints in the numerator and divide by the square root of 12. Now, Hawks asked me to round to 4 decimal places, so I have counting out 4 decimal places, 0.4641. I take a look at the 5th decimal place to see if I should keep the 1 a 1 or round up to a 2. Because the 5th decimal place is a 4 or below, it's a 0, I'm going to keep it a 1. So I have 3.4641. And we click submit. And yay, we get it right. So that's how we will do all of these mean and standard deviation questions in 8.1. Now let me show you how to take a look at these probability problems. So I want to show you how to do this out by hand so you get the idea and the concept and you can visualize what's happening for these uniform distributions. And then I will show you how we can use our Rguroo to calculate these probabilities. So for this example, we're talking about cedar trees, and they are uniformly distributed between 4 and 13 inches. Okay, then we want to find the probability that any given randomly selected cedar tree will grow more than 12. All right, let me jump over to my whiteboard so I can draw this out for you. Just give me a minute, because sometimes it takes a moment to power up. Still powering up. Here we go. Okay, so this particular uniform distribution, we are going to say it is between 4 and 13. They told us that they are looking at cedar trees that grow between 4 and 13. So when we say uniform, we are literally saying that it's an equal likelihood that the trees can grow from anywhere to 4 to 13 inches. So the height of a uniform distribution does not change no matter what probability calculation you are calculating. So whether I'm trying to calculate the probability that a tree will grow less than 5 inches, more than 9 inches, between 3 and 8 inches, the height of my uniform distribution doesn't change. So that height formula is going to be equal to 1 over your end point minus your beginning point. So in our case, it would be 1 over 13 minus 4, which gives us a height of 1/9. Now, this is the height for any probability calculation that I want to do within this particular problem, within this cedar tree problem. So if I want to now find my width, so in order to find the probability, it is the area of the rectangle I'm specifying. And therefore, I need to actually draw what area I'm trying to calculate now. What is the probability I'm trying to find? And in this problem, it told me that I wanted more than 12. So 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this little tiny tick mark is 12. So that means that I am really looking for the area in this sliver here between 12 and 13. And I need to know what the width is of that rectangle. So width is what you think it would be. That's supposed to be my bracket. And width, let me erase that. That doesn't look very good. Oh, undo. There we go. So the width of this rectangle is going to be the difference between the end point and the beginning point of the rectangle. So 13 minus 12 gives me 1. Now, if I want to calculate the probability, clear this out. So if I want to calculate the probability that a random cedar tree grows more than 12 inches, it is going to be our width times height. And again, this only works for a uniform distribution. And so that is going to be our width was 1, and we're going to multiply that by our height, which I believe was 1/9. And that gives us 1/9 as our probability. All right, let me stop sharing this whiteboard and head back to our Rguroo so I can show you how to do the same problem using our Rguroo. All right, so if we head over to our Rguroo, we come over here to our probability simulation area, drop down the probability drop down menu, and in our probability calculator, this time select the continuous random calculator, not the discrete one. Okay, again, we have our mode on top of the calculator, which we will in chapter 8 need to be very conscious of. We are trying to calculate a probability Therefore, we want the mode that's pointing towards probability. Normal distribution is going to be what we use after this section. This section is the only one that we would have to change it to uniform. Notice that they say, okay, well, what is your min, your A, the beginning of the problem? What is the end of the problem? In this case, it was 4 to 13. So the min and the max have nothing to do with the probability you're calculating. It has to do with the overall problem's min and max for the uniform distribution in total. So notice if I look back here at the Hawk's problem, it says that for this uniform distribution, it exists between 4 and 13. So that's your A and B. Has nothing to do with actually the specific probability you're trying to calculate. Recall back to the picture that A and B needs to be identified to calculate the overall height of the rectangle, but the width has to do with what the probability is that you're calculating. So greater than 12, I need to select above and type 12 in here. You will notice there is no longer a checkbox in the continuous random calculator, and that is because being greater than or equal to 12 and greater than 12 are infinitely the same probability. Because now it's not greater than 12 in discrete probabilities was 13. There's a whole jump to another number, but now greater than 12 means 12.0000000000000001. Okay, so infinitely close to 12 that greater than and greater than or equal to are the same probability rounded to 4 decimal places. When I hit my eyeball, I then get the calculation of 0.111. When we did it out by hand, we got 1/9. So let's just double check that those are the same. And they are. So whether we do it out by hand or whether we type it into Rguroo, we will get the same answer. Okay, the Rguroo calculator is fairly simple to use, so I strongly recommend practicing in Rguroo since we will be using Rguroo for the rest of the semester. But those mean and that standard deviation formula you will have to do by hand. Thank you for listening.